All right, week 5 of distance learning. So for this one, we're going to shift away from just looking at area and perimeter and start to look at 3D figures now instead of 2D with surface area today of prisms and cylinders. So we're going to see a few vocab words: lateral face, lateral edge, base edge, altitude, height, lateral area, axis, composite solid, regular pyramid, slant height, right cone, oblique cone. And so we're going to look at pyramids and cones too, by the way. Forgot to mention that. So lateral area of a prism is just the surfaces that are not the base of the prism. So you're finding the area of the surfaces that are not the base. So it's just the perimeter times the height of whatever the base is. So the perimeter of the base. So here we're going to find the lateral area of a regular hexagonal prism. So we just need to find the perimeter. So our perimeter here is going to be 6, because it's 6 sides, times the length, which is 5. So that's 30. So then our lateral area is the perimeter times the height. So 30 times 12, which is 360 centimeters squared. This next part, we're going to look at surface area. So all this is doing is taking the lateral area and adding in the area of the two bases of the prism. So this one just wants us to find surface area, so we have to find lateral area in the process. Because surface area is equal to the lateral area plus 2 times the area of the bases. So our lateral area is going to be the perimeter times the height. Again, here we have a base. There's a couple options here. You can do the bases of the rectangle, but that doesn't make much sense because you have 2 squares and you have 4 of the rectangle. So we want to use the square. So the perimeter is just going to be 4 times 6, and then our height is 12. So our lateral area is going to be 24 times 12, which is 288. So now our lateral area, or not our lateral area, the area of our base is going to be side squared because it's a square. So 6 squared, or 36. So our surface area is equal to 288 plus 2 times 36. 36 times 2 is 72. So that's 288 plus 72. So that'd be nice round. 360, and our unit is square centimeters. So now we're going to look at cylinders. They're kind of the same exact concept. They still use the lateral area plus 2 times the area of the base for surface area, but our lateral area now is going to be 2 pi RH, and that's pretty much always what it is, just because it's a cylinder, and cylinders can't suddenly have a different base shape. They're always going to be circles. So this one wants us to find both lateral area and surface area, and we're going to find the lateral area in the process of finding the surface area anyway. So surface area is lateral area plus 2 times the area of the base. For cylinders, the lateral area is 2 pi r, the circumference, which is the perimeter for a circle, times the height. So 2 pi times our radius. Oh, our cylinder didn't show up. Hold on. Let me do something real fast. There's our cylinder. I don't know why that was on a different animation for the PowerPoint, but there's where we were. All right, so our radius is 14, and our height is 18. So this multiplied out is going to be about 1,583.4 square feet. There's our lateral area. The area of our base is just going to be 2 pi r squared, or pi times 14 squared. Which is 615.8 square feet. We need to double that for our surface area. So the 1583.4 plus 2 times the 615.8. And that gets us our surface area. Which is 2,814.9 square feet. This next one here, now we're finding the radius of a soup can. So we are given two things. We're given the height of the soup can, that's the 8 inches on the right. We're also given that bottom part, which is our circumference, because that's what's going to wrap around. So that means that the 15.7 is equal to 2 pi r. Really not sure what this problem has to do with what we are missing here, but that's fine. I guess what we could do also is find the area of the whole thing and then use that as the lateral area, but really that's just redundant. We end up multiplying by the 8 and then dividing by the 8, so that's kind of redundant. So let's just divide by 2 pi. And we get our radius, which comes out to be about 2.499 inches. So now we're going to take a look at lateral area of regular pyramids. So this one's a little bit different. Pyramids don't have two bases, right? So we can't have that going on anymore. It's 1/2 of the perimeter of the base times what's called the slant height. So that's the height as it goes up the side of the pyramid, instead of going from the base up to the vertex at the top. So finding our lateral area again, lateral area here is 1/2 the perimeter times the slant height. Our slant height is 5, it's given to us, and it's a square pyramid, so our perimeter is just going to be 4 times 2.5, which is 10. So our lateral area is 1/2 of 10 times 5. 10 times 5 is 50. Half of 50 is 25 square centimeters. So now we're going to take a look at surface area. All we have to do here is add the area of the base. So same idea as the last stuff. It's just the lateral area plus the area of the base, but 1 time for the area of the base because there's only one base. So here we want to find just the surface area. The surface area is the lateral area plus the area of the base. Our lateral area is 1/2 the perimeter times the slant height. And our perimeter is equal to, so this is also a square pyramid, 4 times 8, or 32. So the lateral area is 1/2 of 32 times our slant height, which we are not given, so we have to find it. So our slant height is the hypotenuse of the triangle formed by the dotted lines there. So the square root of 6 squared plus 4 squared, 36 plus 16, square root of 54. No, 52. We'll just leave it like that and get our lateral area and round it. It comes out to be about 115.4 meters squared. So now we need to find the area of the base, which again is a square. So the area of the base is side squared, or 8 squared, which is 64. So now we just got to add them up. Surface area is going to be 115.4 plus 64, which comes out to be 179.4 square meters. All right, so this next one we have a regular pyramid again, looking for the surface area. This time, though, the base is a hexagon. So a little more complicated because finding the area of a hexagon, again, needs to have some things like the apothem and the side length. We have the side length. We know a number of sides because it's a hexagon. We don't have an apothem, though, so we don't need to find that. So surface area, again, is the lateral area plus the area of the base. So we find the lateral area is fairly easy here. 1/2 of the perimeter times the slant height. The perimeter is 6 times 10.5, 10.4, sorry, which is 62.4. So then our lateral area is 1/2 of 62.4 times our slant height of 15. It's 468. And the base is going to be the problem here. So finding the area of the base will be 1/2 the apothem times the perimeter, which we already found. The apothem, though, is going to be equal to So drawing a picture of the triangle we're thinking about, it's not using the slant height, the 15 centimeters. This is our apothem of the base. This is 5.2, and this is 10.4. So it's that triangle. So it's going to be equal to the square root of 10.4 squared minus 5.2 squared. Which again, we do have a 30, 60, 90 triangle, so really it's just going to be 5.2 to the bottom times square root of 3. Instead of using Pythagorean theorem, make it a little bit easier on ourselves. Use those special right triangles. So now that we know that, we can go ahead and plug that in. So the area of our base is 1/2 of 5.2 times the square root 3 times our perimeter, which we got was 62.4. So our area of our base comes out to be about 281.00, so we'll just leave it as 281. So now we go ahead and add everything up. The area of the surface area, lateral area that we got of 468 plus 281.0. So our surface area comes out to be 749.0. And our unit centimeters squared. So our next one, so now we're going to look at surface area and lateral area of cones. Same idea, just different formulas. Because it's a cone, it's got a base that's a circle. It's the only change. All the stuff is just taking circle things and applying it. So we want to find the lateral area and surface area of this cone. So again, the surface area requires us to find lateral area in the process. So the lateral area of this is going to be 1/2 the circumference, or in this case, it's just pi r L, because it'd be 2 pi r for the circumference of the circle, which is the circle's perimeter, and then we'd be multiplying it by 1/2 anyway, so just might as well get rid of that. So pi times 1.4, and we're missing our slant height, so we need to find that. That is going to be square root of 3.2 squared plus 1.4 squared. So that is 3.49 centimeters. Again, rounding, which I don't like, but whatever. So pi times, I already had that written down, times 3.49. Then we multiply that out. And that gets us 15.7. Nope, 4 centimeters squared. So there's our lateral area. The area of our base is pretty simple. We're just going to do all the surface area stuff together. So our lateral area of the 15.4 plus pi r squared. Our radius is 1.4 squared. And when we calculate that, we get 21.5. So now this next one takes cylinders and cones and puts it all together. It's 2 of them together. So a cylindrical storage building has a base, missing the E for some reason, with a radius of 6 feet. The conical roof is 4 feet tall. The entire building is 12 feet tall. We want to find the lateral area. So let's draw a picture of what we have here. So it's something like this in 2D. The entire thing is 12 feet. The cylinder part is 8 feet. The cone part is 4 feet. We only know the 8 feet part because it's 12 minus 4. The radius is 6 feet. And that's everything we need. So we're just finding lateral area. So lateral area of a cylinder was 2 pi RL. Or pi RH, sorry. So that is 2 pi times 6 times 8 for the cylinder. So that's going to be 2 times 6 is 12. 12 times 8 is 108. Sorry, 96. Went too high. And so it's 96 pi. And that comes out to be about 135.9 square feet. That's for the cone, or the cylinder. For the cone, that's going to be pi RL, the slant height, which again we don't have. So we do need to find our slant height. So this part here is 6, 4, 6, and then our hypotenuse is what we're looking for. So that's going to be L equal to the square root of 6 squared plus 4 squared, which we did earlier was the square root of 52. So we'll leave it just like that. So pi times 6 times the square root of 52 is 30. Oh, wait, hold on. I wrote the wrong answers down. This is the 301.6. This one is 135.9. And the total adds them all up, and that is 437.5 square feet. Sorry, I messed those up. Feeling a little rushed. See you next time.